Hello everyone, my name is Kunal and currently I am pursuing BTech degree in Department of Aerospace Engineering. I am your mentor in subject of mathematics and today we start integrals in which we read indefinite integrals first. So like this is our function fx, ये हमारा function fx है and d by dx, if we differentiate this function with respect to x, so here it is also written as f prime of x. Now df of x is equal to f dash f prime x into dx. It follow the previous step and this is the sign of integration, and if we integrate it df of x, so we can also write it as integral sign of f dash of x dx, because df of x is equal to f prime of x dx. So the basic thing we learn here is this is the sign of integral. Now if we integrate it f dash x dx, we get fx and plus some constant, and this constant is called integration constant. Now what is df of x is here? So as I previously said, df of x is differentiation of a function f with respect to x, or we can say that df of x is a very small section or elementary section of the function fx. Now integration is nothing but a reverse process of differentiation. इंटीग्रेशन में हम करते क्या है, जैसे डिफरेंशिएशन में किसी फंक्शन को डिफरेंशिएट कर रहे होते हैं, वैसे ही इंटीग्रेशन में डिफरेंशिएशन का रिवर्स प्रोसेस होता है. लाइक यहाँ पे समझाया गया है, लाइक डी बाई डी एक्स ऑफ एफ एक्स. सो दिस इज डिफरेंशिएशन. we differentiate this function f of x with respect to x. So we can write, as I previously said, we can write it also as f prime of x, or we called this f prime of x into gx. I'm again repeating that this is differentiation of function fx with respect to x. We can also write it as f prime of x, and we name this function f prime of x in its gx. So we just named it f prime of x is gx. Now, what about integration? So if we integrate this function, which is f dash x, this is the sign of integral with respect to x. So we can also write it as f dash of x dx, because we name f dash x gx. Then we also, so the integration is a reverse process. So again, we get the function fx. First, I differentiated a function fx with respect to x. We can write it as f prime of x, and we named it gx. And now I showing the reverse process, how the integration is a reverse process of differentiation. So what I'm doing is taking the integral of the function gx, which is actually the f dash of x. And how can we write the f dash of x और the f prime of x को अपन कैसे लिख सकते हैं? तो हमने लिखी है d by dx f of x. So here we get f of x. So यहाँ पे ये क्लियर हो रही है कि इंटीग्रेशन इज द रिवर्स प्रोसेस ऑफ द डिफरेंशिएशन. नाउ वी टेक इट an example like with showing the integration is the reverse process of differentiation. So here we take this is a function fx, which is of form this function df of x. It is nothing but a elementary section of sine inverse 2x by 1 plus x square. I'm again repeating, d sine inverse 2x by 1 plus x square is nothing but a elementary section of sine inverse 2x by 1 plus x square, or it's a very small section of sine inverse 2x by 1 plus x square. So when we integrate it with respect to dx, so when we integrate it with respect to dx, so if we recall here, some slides left. So how can we write it as like d f of x? We can also write it as f dash of x dx. And when we integrate it, we get the fx. So when we apply here, so when we apply here, so when we apply here, d sine inverse 2x by 1 plus x square, we can also write it as differentiation of sine inverse 2x by 1 plus x square dx. And when we integrate it, we get it sine inverse 2x by 1 plus x square. So it is of the form, if we integrate d f of x with respect to x, so we get the function fx. Actually, this question, is based on this, on this. It is of the form d f of x, and we can also write it as f dash of x dx. And when we integrate it, we get the fx. Whatever inside the d, we get the function as its integral. Now, another example which showing uh, that the integration is the reverse process of differentiation. So the another example is, if we take like d by dx cos x plus 5. So we are actually doing differentiation of, this is a function, named it gx is equal to cos x plus 5. And when we differentiate it with respect to x, so what we get by the property of differentiation, first we differentiate this function, then we differentiate this function. So if we differentiate the cos x, we get minus sin x. The differentiation of cos x is minus sin x. And plus differentiation of a constant. 5 is a constant number. So when we differentiate it, we get 0. So what is the differentiation of a function cos x plus 5? Minus sin x only. And now when we integrate this function, when, as like I'm saying, when I integrate this function, uh, sorry, when I differentiate this function with respect to x, we get minus sin x. And now I'm saying like integration is the reverse process of differentiation. So if we integrate it, we get this function. Okay. So if we integrate the minus sin x with respect to x, so minus sign, this is the integral sign, minus sin x dx, we get the cos x and plus some constant. But here for this function, the constant value is 5. So later we discuss what represented. But here the value is cos x plus c. But in this case, the function constant value is 5. Now the next example I'm showing is d by dx cos x plus 8. D by dx cos x plus 8 is my function. So again, I repeating that this name it gx. And when we differentiate it, we are doing a differentiation of this function, named it as gx. Gx is equal to cos x plus 8. So whenever I differentiate it, what we get by the property of differentiation, first we differentiate this part cos x1, and then we differentiate the constant part. So when we differentiate it, the differentiation of cos x is minus sin x, and the differentiation of constant value is 0. So again, we get the minus sin x, and we know that the integration is the reverse process of differentiation. So if we integrate this part, we get this function, because it's the reverse process of differentiation. We're doing differentiation and we're getting the product, and then we integrate it and getting the initial function which we differentiate. So minus sin x integration will be cos x, because it's the reverse process. So cos x. Again, here we get some constant c, but implicitly we take it as value 8, because the function value is 8. We are just verifying it. Constant can take any value, but the given function has a constant whose value is 8. So we implicitly take the constant value as 8. So now the question arises ki when we integrate a function, we get a function which is differentiable. Basically, integration is the reverse process. I'm again repeating of differentiation. So integration, when we integrate a function, we get a product which is differentiable and plus some integral constant. Now the integral constant can take any value, Here we take the implicitly 5 and 8 as according to our given function, but this constant can take any value. So what this actually represent? So now we're moving to the geometrical interpretation of the integrals. So now the geometrical interpretation of the integrals is like this is the integral of f dash of x dx. We get fx plus constant. So what it represent? It represent a family of parallel curves which has value c1, which has value c2, which has value, maybe the constant value will be 0. So y is equal to the fx. When we integrate this the integral value which we get, what it represent? It represent the family of the parallel curve. Okay. So like if we go to the previous problem again, what we get here, wait, uh, what we get here is in this problem, this is our a function which is differentiable, and in this case, like we get the value cos x plus 5 and cos x plus 8. So here the constant value c1 will be 5, and the c2 will be 8. But the integrable function is the same in both cases. So what we get, these both curves are same. Cos x plus 5 and cos x plus 8 are the parallel curves. Okay. So what the geometrical interpretation say? Ki, the fx plus c or whatever the value we get after integrating function, we get a family of curve which are parallels. Okay. Now we try to operate this thing. This is integral sign. The function which are written, or the function which will gonna integrate, called as integrand, and with respect to basically जिसके respect में हम integrate कर रहे होते हैं, which is called as integral element, and the result which we get apart from constant is called integral or the antiderivative. Antiderivative, why? Because it's the reverse process of the differentiation. So differentiation is called a derivative, and so the integration is called as antiderivative. So this is integral sign. जो फंक्शन को हमने इंटीग्रेट करनी है उसे इंटीग्रेंड बोलते हैं, जिसके रिस्पेक्ट में कर रहे हैं उसे इंटीग्रल एलिमेंट भी बोलते हैं, and the result we get, which is called as integral or the antiderivative, and here we get some constant value which is called as the integration constant. Now we are going to see some basic formula which जो कि गेट बाय हर्ट हो जानी चाहिए, याद हो जानी चाहिए अच्छे से, ताकि सवाल करने में इजी हो. So these are some actually all जितने भी यहाँ पे फॉर्मूले दिए हुए हैं सारे के प्रूफ कैसे आती हैं, तो रिवर्स ऑफ डिफरेंशिएशन से हमने करनी है. सो इफ वी टेक लाइक इंटीग्रेशन ऑफ x to the power n, where n is any integer, basically any rational number, something. Okay, n is integration of x to the power n, where n belong to the real number. So its integration will be x to the power n plus 1 by n plus 1. बेसिकली एक पावर बढ़ानी है और जो बढ़ा हुआ पावर आया है उससे डिवाइड कर देनी है, एंड वी पुट द कांस्टेंट वैल्यू 1/x integration will be ln x plus c, e to the power x, e to the power x plus c, a to the power x, a to the power x by ln a plus c sin x minus cos x sin x. Now here we notice one thing. If we differentiate this, if we differentiate this function, we get this function. Basically, if we differentiate the integrals or the antiderivative, we get the integrand. अगर हमने इंटीग्रल्स को डिफरेंशिएट करा तो हमें वापस से क्या मिल जाएगी, हमें वापस से मिल जाएगी इंटीग्रेंड. Like if we, what's the differentiation of ln x? 1/x. So 1/x. What's the differentiation of e की power x? E की power x. What is the differentiation of a to the power x by ln a? So the differentiation of a to the power x is a to the power x ln a, and the ln a got cancelled, so we get a to the power x. What is the differentiation of cos x? The differentiation of cos x is minus sin x, and the sign minus into minus will be plus, so we get the sin x. What is the differentiation of sin x? Cos x, as you read in your differentiation basics. So these are some, like differentiation of tan x will be the sec square x. So the integral of sec square x is tan x. As we know, as you read in differentiation basic, like tan x, अगर tan x को differentiate करें, so we will get sec square x. So if we integrate the sec square x, we get the value tan x, because the integration is the reverse process of differentiation. Now we move forward. Now, we know that differentiation of cot x is minus cos x square x. So if we integrate the cos x square x, we get the minus cot x. And same way, like differentiation of sec x will be sec x tan x. So if we integrate sec x tan x, we get the value sec x and the plus some constant. If we, again I'm saying, these all you get out in differentiation basic. Like if we differentiate cos x, so we get the minus cos x cot x. So if we integrate the cos x cot x, we get the minus cos x and plus some constant. Now the thing says, यहाँ पे जो मेजर पॉइंट पे हमें फोकस करनी है वो ये है कि if we differentiate the integrals, we get the integrand. If we differentiate the integrals, we get the integrand. Okay. So I think from till now, you all get clear. Now I'm going to look into some properties of integrals. So the first property is like this is function a fx, which name as fx, and operator plus minus, and a second function gx, which named as b. And if we integrate this function with elementary element x, so what can we do? We can split this function into two parts. Like we can split these integrals into two parts. Like this is function 1 and this is the function 2. And both are uh, collective with a operand plus and minus. So we can split this into two function, which is differently, like this way. First, the integration of fx dx plus minus integration of gx dx. So what we do here is, if any function given, if any two function given in such a way, like it's collectively written like in with the operand plus and minus. So we can split it into two function, which is like as fx dx plus gx dx, and we independently integrate this both function. We in, we independently integrate this both integrand. Now the second property is a function fx is given, which is multiplied by some constant k. K is any real number. K belongs to the any real number, and k into fx dx. And when we integrate this function, actually what it's written is a function fx is given and which is multiplied with a constant k which belongs to the real number. And when we integrate this integrand, what we can write, we can take k, this the number k which is constant out of the integral. Like if we integrate 2 cos x, if we to write like if I have to integrate 2 cos x, so what we can write it as with respect to dx. So right now we know that integration of cos x is sin x. So what we can take, we this is our okay. So we can take this k value out of the integral. We can, sorry for my handwriting, cos x dx. And now we know the integration of cos x is sin x. So what we get, 2 sin x. Rely more and more on my word because my handwriting is very poor on this. Okay. So what I'm trying to say, this is our an example just for clarify you is integration of 2 cos x, which fx is cos x and the k is 2, and the elementary element will be like dx. So what we can write this whole integrand as, we can take 2 out of the integral. So we can take 2 out of the integral and then we integrate this function fx dx. So what we get, the cos x, the integration of cos x is sin x. So the integral is 2 sin x plus c. And now again I'm saying if we differentiate this integral, so what the differentiation of integral, what we get? We get the integrand. So 2 sin x plus c, when we differentiate it, what we get? 2 cos x plus 0. So what we get? 2 cos x. Okay, so this is the second property of integration. Now I'm taking the third property, and it is we are first integrating a function fx with respect to dx, and then whatever we got here, we differentiate that function with respect to x again. So this is our integrand, and when we differentiate it, we got the integral. And when we differentiate the integral, what we got? Integrand. As I previously said, whenever we differentiate the integral, we got the integrand. So when I integrate this function fx dx, what we get? We get an integral, and when we differentiate that integral, whatever here we got, named it gx. When we integrate the function fx dx, let us suppose we got a gx. And when we differentiate that integral, what we get again as integrand. What's the integrand is fx. So we get fx. I think this will be clear to you. If not, then I'm again repeating. Okay. So what it is here, mark my word. I'm actually saying when we differentiate the integral, we get the integrand. So the first stage integrand is fx here, which I'm integrating with the elementary element dx. Now what I am doing, we get some integral here, named it as gx. When we integrate this function, we get a integral, named it as gx. When we differentiate that integral, because we are differentiating whatever we got here, we differentiating that. We differentiate that. So whenever we differentiate the integral, we got integrand. And what the integrand of this whole function? This whole function integrand is fx. So we got the answer as fx. So I hope you understand the property uh, of the integral. So what we actually read till now. So we read what is integral, what is integration is, and some basic formula and its geometrical interpretation, and some clear knowledge about the integrand, integral constant, integral and integral element, and some basic formula and some property. Now we go through the fourth property. And what it is, if we integrate a function with respect to x, let us suppose we get gx plus c. Like if we integrate this function fx, if we integrate, we get integral as gx plus some constant. Then if we integrate f of ax plus b, like same function with a coefficient of a x plus b dx, what we get g ax plus b by a. सो ये कैसे आया, इसे समझते हैं थोड़ा प्रूफ से. लाइक ये जो x की कोएफिशिएंट थी वो डिवाइड में कैसे आ गई, उस पे जरा देखते हैं. सो व्हाट वी डू इज we take this function ax plus b as t, and when we so what we take this function ax plus b as t. So when we differentiate it ax plus b with respect to x, so what we get the differentiation of this function. First we differentiate, like this is constant, so first we take a as a constant. A actually is constant, so first we differentiate x by product rule, and then we differentiate a, so we get 0, so we get the differentiation as a. And when we differentiate t with respect to it, we get dt by dx. So what I got here is a dot dx is equal to dt. Wait. So what we got here, a, like cross multiply a dot dx is equal to dt. And now our function is changed. What we get, like we put ax plus b is equal to 2t. So here my function is, this same function can be written as f of t. And what is my dt? So what is my dx? Integral element. The integral element will be like dx is equal to dt by a. And we know from the property, like if we integrate this function ft dt, what we get 1 by a f of t dt. And what is t? Vt ax plus b. I'm again repeating that. What we do, I substitute a value of ax plus b as t. I just substitute the value of ax plus b as t. And then what I do, I just differentiate it to get the value of integral element. Now our integral changes, but it remains same. Now my integral changes. Actually, its written format is changing. The value will be same. So it now the f of ax plus b dx can also be written as f of t, where t is equal to ax plus b, and dx we can write dt by a as you clear from the above mentioned steps, and which is equal to 1 by a f of t dt. And when we integrate this, what we get? 1 by a zt plus c, because the integration of fx dx is equal to gx. So the integration of ft dt is equal to zt, and now I substitute the value of t here. So what I we get? Ax plus b. So 1 by a g of ax plus b. I think it's clear to you. Just substitute some value and then try to find the integrand in terms of that and integral element in terms of that substitute value, that substituent value. Now I move forward. Now I go through some examples here. Like here, our function is, our integrand is 1 plus x ka whole cube divided by root under x, and our integral element is dx. So how to integrate it? So the first way of approach, actually in next class, uh, we read some technique to integrate, like how to approach any integrand. So some basic rules, some basic techniques, uh, we are actually gonna read in next class. But for now, this is our given integrand and we have to integrate it. The function is 1 plus x ka whole cube divided by root x. So the one way of approach is, we just opened it in the form of a plus b whole cube. So what the value of a plus b whole cube will be? A cube plus b cube plus 3a square b plus 3ab square. So if we watch here, if we take a as 1 and b as x, so what we get? A cube plus b cube plus 3a square b plus 3ab square, and divided by root x, and just divide it. So what we get? X to the power minus 1 by 2, x to the power 5 by 2, 1 minus 1 by 2, 3 root x plus 3, x to the power 3 by 2, by some basic exponential concept. So what I do here, I just use some basic rules of exponent. I think you all got it. If not, then let me write what I do here. I just do like a to the power x, a to the power m, a to the power n. We can write it as a to the power m minus n. So I think you all got it. Okay. So what I do here, 1 by root x will be x to the power minus 1 by 2, and 3 minus 1 by 2, x to the power 5 by 2. 3x to the power 1 by x to the power 1 by 2. So 1 minus 1 by 2 will be the root x. And similarly 3 to the power x, 3 into x to the power 3 by 2. Now, we actually previously read some basic formula. This is of the form x to the power n, where n is any real number. And in this case, n value minus 1 by 2. So what we do? We increase its power by 1, and whatever we got here, we just divide it by, and we just divide this function by that number. Basically हिंदी में कहें तो एक पावर हमें बढ़ानी होती है, और जो भी बढ़े हुए पावर आया उससे डिवाइड कर देनी होती है. So what we do here is x to the power minus 1 by 2 plus 1, and what I got? X to the power 1 by 2. So we divide this function by 1 by 2, so we get 2 root x. Actually, let me show you. So what I do here is, I just like x to the power minus 1 by 2 and we integrate this. So what I have to do, this is the form x to the power n. So what I do minus 1 by 2 plus 1. We have to raise its power. And whatever I got here, we have to divide it. So minus 1 by 2. So what we get? We get 2x to the power half. So we can write it as 2 root x. Got it? I think it will be clear to you. Now if we look this function, we applied some property here. The first property, like if the function, this is a function, first function, second, third, fourth, collectively written with the operator plus. So what we do, so what I do here, we just integrate each and every function independently with respect to dx. So what I got, 2 root x, we just apply the form x to the power n and basic integration. It will be x to the power n plus 1 by n plus 1. So we get 2 x to the power half. So 2 root x. And similarly, if we repeat for those, we get the value 2 root x plus 2 by 7, x to the power 7 by 2 plus 2 x to the power 3 by 2 plus 6 plus 6 by 5, x to the power 5 by 2 plus constant. Actually, whatever here written is just of the form of integration x to the power n, and try to solve each and every single. Don't copy those steps. Take it as question and solve by yourself. And wherever you got some mistake, try to match with this solution. Now the second question is, again, it's a combination of function which is written as uh, operator minus or divide, whatever. So how can we write it as? We can write it as, now here are some basic rules of exponent. We can write 2 to the power x into 2 minus 5 to the power x divided by 5. So what we do here, we know the integration of a to the power x will be a to the power x by ln a. So we just use that. Look at here. I'm clearly saying how can we write those function as? We can write it as 2 to the power x plus 1 minus 5 to the power x minus 1. So I just doing 2 to the power x dot 2 minus 5 to the power x dot 1 by 5. Basic rules of exponent. And now we take this. Now I applying the property 2. This is k and this is a function. So we take k out of the integral. So I take the k out of the integral. So what I get, 1 by 5 to the power x. We can write 10x to the is equal to 2 to the power x into 5 to the power x by some basic property of exponent. And now here I got an integrand in the form of a to the power x, like where a is 1 by 5 to the power x. So what is the integration of a to the power x? As I mentioned above, some basic formula, you can go through it, which is equal to a to the power x by ln a. So the value is 1 by 5 to the power x, which is a to the power x by ln a, where a is 1 by 5. So log of 1 by 5. Similarly, minus whatever k will be gone out of the integral. So 1 by 5 and 1 by 2 is our a and a to the power x. So a to the power x by ln a n plus constant. So here we apply the property 1, which is we have to integrate independently. Here we apply the property 1 and 2 as well, because we take the k out of the integral. So this is the practice on our property 2. Now I go through the property 4 or 3, whatever it is. The property 3 is if we integrate, like if we integrate the sin x, mark my word, if we integrate the sin x, what we got? We got the minus cos x, right? If we integrate the sin x, we get minus cos x plus c. But here it is in the form of sine 5x plus 3, which is of the form a function of ax plus b form. So what we have to do? What we do, we just integrate it, and whatever in the coefficient of x, we just divide it by. Go through the property. Wait. Go through the property number. We just integrate it, and whatever in the coefficient of x, we just divide it by. And we also prove it. So once you go through it. So it same sine 5x plus 3. The integration of sine x will be minus cos x 5x plus 3, and we have to divide by the coefficient of x. So here we apply the property 1 and 2, and here we apply the property 4 actually. So what we get? We have to take the function, integration of the function sine x. So what is the integration of the function sine x? It is minus cos x. So minus cos 5x plus 3, whatever in the inside. And ax plus b, we divide it by the coefficient of x, so by 5. Similarly, here the parent function is e to the power x. It is of the form e to the power x, but x is written in the form of ax plus minus b. So what we do, what I know by basic formula is e to the power x integration will be e to the power x, but it is the form of 7x minus 3 or ax plus b, whatever it is. So we apply the property 4 here, and what we got, e to the power 7x minus 3 divided by the coefficient of x by 7. Whatever it here written is the it is basically here a to the power x dx. We integrating the function a to the power x. So we know its integration is the reverse process of differentiation. So first we write a to the power x as, by using the basic logarithmic concept, we can write it as e to the power x ln a. And when we integrate it, when we integrate this function, so its parent equation is e to the power x, but it is written as in the form of ax plus b. Wait, I have to explain it because it is little bit complicated. Okay, I have to, okay. So what I'm saying is, like a to the power, what when a to the power x, we can write it as e to the power x ln a. Okay, and this function is written in the form of actually e to the power some a, capital A, where capital A value will be ln small a, ax plus b, where b is 0 and small a and capital A is equal to, here I write it as capital A is equal to ln a. We just compare. I just compare it to the given function. Okay, so we first write this a to the power x by using some basic logarithmic concept, exponential concept, a to the power x ln a. And when I get e to the power x ln a, we can also write as e to the power x plus b, where capital A is ln a and b is 0. And we know that when we integrate e to the power x, what we get? E to the power x as well. So e to the power x ln a, and we divide it by coefficient of x by property 4. So when we divide it, e to the power x ln a by ln a, and e to the power x ln a is equal to x. A to the power x by ln a. This is basically the proof of integration of a to the power x. Moving to the next, these are some practice questions which you have to solve, and wherever you stuck, try to look into its solution as well. but try to solve uh, by its own. There is some 10 practice problem. So try to solve it. Now here is some concept which we learn in next class, or we discuss some this problem. Thank you.